Hello, welcome to the 9th session of the Introductory Biostatistics Distance Learning course. Today we're going to do the Stata tutorial on how to do hypothesis tests, which is what we spent the last two sessions on, sessions 7 and 8. So session 9 will be the accompanying Stata tutorial for hypothesis testing. We're one class ahead of schedule, which is good news. We might be able to cover more than we expected, but if you were looking at the syllabus, we're a little bit ahead. We're on session 9 and we're doing the Stata tutorial for hypothesis testing. Okay, so here I am in Stata, which is on the screen here. I have the SEPO dataset loaded. Remember, that's the dataset that we've been working with all along. It's the randomized clinical trial of different treatments for HIV-infected patients. And it occurred in Botswana. Okay, so you'll remember in a previous session we created a confidence interval for the mean baseline CD4 count. Baseline CD4 count means the CD4 count that patients had when they first entered the study before they started any treatment, and CD4 count is a measure of their immune status. So the lower it is, the sicker a patient is, the higher it is, the healthier they are. I apologize if you're an infectious disease doctor listening to this, you know much more about this than I do. Just not sure who the audience is, so trying to cover everything in case there's someone with a little bit of a different background. Okay, so again, if I wanted to create a confidence interval for the CD4 count, remember that the variable in this data set is called CD4, appropriately enough. So I would just type in CI for confidence interval and then CD4 and hit enter. And so you can, and it gives me all this information. It tells me that there are 650 patients with a CD4 count, and the mean is 191. The standard error is 3.27. Remember, that's a standard error of the mean. That's not the standard deviation. And then based on both the mean and the standard error, we can then construct a 95% confidence interval for the mean. And it looks like here it goes from 184 to 197. So this looks like a relatively sick cohort of patients because we know that the treatment initiation criteria for antiretroviral therapy is a CD4 count below 200. So it looks like most of the people in this data set are going to have CD4 counts below 200 and be eligible to start therapy. Okay, so that's what we did last time. Now, what if we wanted to do a hypothesis test based on the CD4 count? How would we proceed there? So let's just follow the same build-up that we did in lecture. Remember, in lecture we started with a one-sample t-test, and then we worked our way up to a two-sample t-test. A one-sample t-test was for when we had a continuous outcome, and a CD4 count is a continuous variable, so that's appropriate. Again, always want to think in terms of what kind of variables you're dealing with. Continuous, ordinal, categorical, binary, time to event, and so on. Here we're talking about the CD4 count, which is a continuous variable, so a t-test is appropriate. And so we're going to start with a one-sample t-test. A one-sample t-test, we said, it doesn't really happen too often in practice, but it's a good way when you're just learning the methods to start. So in a one-sample t-test, we say we have a sample of patients, and we want to compare their outcome to a specific number. Okay? That's why it's not really that realistic in real life, because how often do we compare to a specific number? Probably not that often. But it's a good way to start. So let's compare then to a specific number. So suppose I want to look at the CD4 count for only women, for example. So how would I do that? And I'm going to proceed with a hypothesis test. So let me go through the 7 steps for hypothesis testing that we previously described. Okay? So let me see if I can figure this out. If I go to full screen. Okay, so we had 7 steps for hypothesis testing, and the first step was to state the null hypothesis. So state the null hypothesis. Whoops. State the null hypothesis. Okay, so in this case, so we're looking at the mean CD4 among women, right? So I would say my null hypothesis, remember we write it in this way, is that the mean, remember we use Greek letters to denote the mean CD4 among women, suppose I'm interested in whether it's equal to 200. Okay, because that's the treatment initiation criteria. And again, then we want to write the alternative hypothesis, which we can write as either HA or H1, and that is that the mean CD4 among women is not equal to 200. Okay, so you can see why this is a two-sided test, because it could either be greater than 200 or less than 200. So that's why it's called a two-sided test. Okay, so that was step one of our hypothesis test. Step two is to state the type of data we have. Well, we have a CD4 count, which we know is a continuous variable. And that's why, as we mentioned, a t-test is appropriate in this case. Okay, so step three was to determine the type of the appropriate statistical test. Well, in this case, it's a one-sample t-test. One-sample t-test. Why? Because we have one sample, namely the CD4 count among women, and we have a continuous outcome, CD4, that's why a t-test is appropriate. Okay. All right, good. So we're up to step three. We haven't even used the computer yet, and we're up to step three of our 7 steps of hypothesis testing. So step 4 is to state the summary statistics. So we need some summary statistics. So this is where the statistical software comes into play, because there's no need for us to do this by hand. We'll have the computer calculate it for us. Okay, good. So how do we do this in Stata? Let me exit out of here and go over here. Okay, so if I want to do a t-test in Stata, remember in Stata we can do things, most things in at least 2 different ways, probably even more. We can use the command window down here, or we can use the drop-down menus. And so since I don't know the command for a t-test, I'll use the drop-down menus. So I'll go to Statistics, Summaries, Tables, and Tests, and then Classical Tests of Hypothesis. Remember, we're now doing hypothesis testing. And then I'm going to choose a one-sample mean comparison test. You can tell we're at the beginning of the course, we're choosing all these first options, but that's okay, we'll get through the rest of them as the course goes on. Okay, so I'll select this one-sample mean comparison test. You can see I've already entered these things, but if you're coming on this new, you would see this kind of blank here. So I could use the drop-down menu to select the variable name, and then I'll choose CD4, and my hypothesized mean we said was 200, and I chose that because that's the important treatment initiation criteria, the threshold that physicians used. And then I want to go to this by if in up here, and suppose I want to actually repeat the test for both men and women. So I clicked on repeat command by groups. So I want to do a one-sample t-test for both men and women. Is the mean CD4 for women equal to 200? And is the mean CD4 for men equal to 200? So I selected that repeat commands by groups option, and then I choose the drop-down menu, and I go and I choose sex to define men versus women, and then I'll hit OK. All right. Now you can see here's my output, highlighted in blue now. So up here it says sex equals male, then there's a line, and then sex equals female. So We had talked about the females before, so let's focus on this bottom part, which is now highlighted in blue. And you see we get that same sort of table we got before. Here's the mean for women, looks like it's 188, and the confidence interval goes from 180.75 to 196.06. And so the results of our two-sided hypothesis test, remember the one-sided hypothesis tests are here on the left, on the left highlighted in blue now, and on the right, those are the two one-sided tests. And then in the middle, and the reason I knew that is because it's telling me, look, the alternative is that the mean is greater than 200 over here, and here it's telling me that the alternative hypothesis is that the mean is less than 200. Okay, so if that's your alternative hypothesis, either greater than or less than, then you're in a one-sided test situation, right? But if you're in a situation where the alternative is that the mean is not equal to 200, then you're in a two-sided test, which is what we're going to do far more frequently. Okay? And so now if you look down here, you can see that the corresponding p-value for this two-sided hypothesis test of whether the mean CD4 among women is equal to 200, the p-value is 0.0031. Okay? And so since this is less than 0.05, we're going to decide that, hey, we're going to reject the null and conclude that the mean CD4 among women is not equal to 200. Namely, it appears to be less than 200 because we know the mean up here is 188. Okay? And again, we mentioned this before, this duality between hypothesis testing and confidence intervals, right? So we rejected the null hypothesis that the mean includes 200. And hey, look, that's consistent with what we see from the confidence interval. Because our confidence interval goes from 180.75 to 196, we know that it doesn't contain 200. Okay? So hopefully you can see how these two things are agreeing. The results of the confidence interval and the results of the hypothesis test. The confidence interval did not contain 200, so from there we already could have known that we were going to reject our null and say that, hey, the mean is not equal to 200. Okay? So there's always that duality there. So, so that'll aid in our understanding going forward. Okay. So if we were going to go back to our 7 steps of, I'm not going to write it out, but if we were going to go back to our 7 steps of hypothesis testing, then step 4 would be to state the summary statistic. The summary statistic in this case would be that the mean CD4 among women is 188. Okay? Then the p-value, which is coming from our statistical software package, is this 0.031. Remember, I'm choosing the one in the middle because almost always in medical research we're going to do two-sided tests, two-sided hypothesis tests, and in Stata that's the one in the middle. So step 5 of my hypothesis testing would be to calculate the p-value from Stata, and it turns out to be 0.0031. And then step 6, we want to decide whether to reject or fail to reject the null hypothesis. Well, since this p-value is less than 0.05, 0.0031 is less than 0.05, then we decide that we're going to reject the null. Okay? So anytime your p-value is less than 0.05, you reject the null. Anytime your p-value is greater than 0.05, you fail to reject the null. And again, that's assuming we're operating at a alpha equals 0.05 level, which we almost always are. Okay, so that was step 6, to decide whether to reject or not reject. We decided to reject. And then finally, step 7 is to write our conclusion based on this. So we would say, based on our sample, there is a statistically significant difference between the mean CD4 count in women and the number 200. Namely, it appears that the women in this sample have a mean CD4 count less than 200. Okay, so that would be our final step of our hypothesis test. That would be our conclusion. Okay? All right. So hopefully that makes sense. So now we can say, hey, it looks like we have a sick group. They're all treatment eligible, and so on. Okay? And again, if we wanted to do the same sort of exercise with the men, we could, because we have that output here under sex equals male. And it looks like for them, it would actually lead to a very different conclusion, because their mean is 197, and the confidence interval goes from 185 to 208. And immediately, just from this confidence interval, I know that I'm going to fail to reject the null. In other words, I'm going to get a p-value greater than 0.05. How did I know that? Well, it turns out that the confidence interval contains the number 200, which is the one I'm interested in this exercise, because it goes from 185 to 208. So 200 is in the middle of that confidence interval. So therefore, I'm going to fail to reject. And if I go down here, you can see, here's my two-sided alternative, that the mean, remember the exclamation point means not, so that the mean is not equal to 200 is my alternative. And the corresponding p-value there is 0.623. Okay, so 0.623 is greater than 0.05, much greater than it, in fact. And so I would fail to reject the null, and now I would come to a different conclusion than I did for the women. Namely, I would say that the mean CD4 count among men in this sample does not appear to be statistically significantly different from 200. Okay, so this is kind of neat because we reached two different conclusions for the men and the women based on this hypothesized value of 200. So the women appear to have a mean CD4 count that is less than 200, while the men have a mean CD4 count that does not appear to be different from 200. Okay? All right, good. All right, so that's one-sided hypothesis testing, or sorry, one sample, I apologize. It's good to not get those concepts confused as I just did. So one sample t-test. And so now we said one sample t-tests aren't that common in the literature because there are very few cases where you want to compare a group that you have to a specific number. Remember in our example we were comparing to the specific number of a CD4 count of 200. What happens more frequently is that we want to compare to two different groups. So here you can immediately tell the direction we're going in. What if we want to compare the mean among women versus the mean in men? That would be a two-sample t-test. Okay, so we're no longer comparing to a specific number. Instead, we're comparing the means in two groups. Okay, so again, we can go through the same 7 steps of hypothesis testing. So why don't we do that? I'll clear this out. Whoops. Okay, so my first step again is to state my null hypothesis. And so here the null hypothesis is that the mean, I'm not going to write CD4, hopefully, but you know that's what we're talking about. So that the mean in women, remember I use the Greek letter mu again because I'm talking about the population parameter, equals the mean CD4 count in men. Okay, so my alternative hypothesis in this case would be that the mean in women is not equal to the mean in men. Okay? That's one way of writing it. Let me call that A. Another way I could write it, the same alternative hypothesis, would be to say that the mean in women minus the mean in men is equal to 0. Okay? So hopefully you can see how these two alternative hypotheses are just two different ways of writing the exact same thing. One way we said the mean in women is not equal to the mean in men. The other way we said the mean in women minus the mean in men is equal to 0. Okay? So that's the same sort of thing. Okay? Same way of writing. Okay. So now we want to move to step 2 of hypothesis testing, which tells us we want to state the type of data. So we're going to state the type of data we're working with. And so now, what kind of outcome do we have? Well, it's still our CD4 count. So our outcome is still continuous. The CD4 count is a continuous variable. But now we have a predictor, right? Or an explanatory variable, or a covariate. These are all words that mean the same thing. Predictor, covariate, explanatory variable. Namely, it's a person's gender or sex. So that here is a binary or dichotomous variable. Sorry, we have so many words to say the same thing. So binary or dichotomous, they mean the same thing. Namely that there are 2 levels. And the reason we have a binary or dichotomous predictor is because it's either men or women, okay? So since we have a continuous outcome with a binary predictor, it turns out that in step 3, where we need the appropriate statistical test, well, it turns out for a continuous outcome with a binary predictor, the appropriate statistical test is a 2-sample t-test. Okay, so we're going to compare the mean for women to the mean for men. All right. So now for step 4, which was to state the summary statistics, we're going to move to Stata. So let me move over here back to Stata. Okay, so now let me illustrate how I would do this with the command window, and then we'll show with the drop-down menus as well. So here I can go to the command window and I can type t-test, so 2 T's, t-test, and no space in between them. And then CD4, because that's our outcome variable, comma, by, and then again no space but an open parentheses, sex. Okay? So again, just to slow down a bit, t-test with no space in between, then a space, CD4, comma, space, by, open parentheses, and then sex, which is for a male versus female, and then close parentheses, okay? And now you can see this output here, which says a 2-sample t-test with equal variances. Remember in lecture we talked about we can have the assumption of equal variances, we can relax that assumption and assume unequal variances and so on. But for now we've assumed equal variances just for this illustrative example. Okay? So what do we see from this output? Well, it gives us the mean CD4 among men, the mean CD4 among women. Those are our summary statistics. And just as we saw before, the mean CD4 among men appears to be higher, 197, versus the mean CD4 in women, which is 188. And here are the confidence intervals. For men, it goes from 185 to 208, while for women, it goes from 180 to 196. Okay? So again, just looking at the confidence intervals, we should be able to predict the outcome of our test, our hypothesis test. So what do we notice about these confidence intervals? One goes from 185 to 208, the other one goes from 180 to 196. So what do I notice about them? Well, they overlap, okay? So there's some overlap in these confidence intervals. And so immediately from the fact that these two confidence intervals overlap, I can tell you that the hypothesis test is going to fail to reject. In other words, it's going to have a p-value greater than 0.05. Okay? So hopefully that makes sense. If the confidence intervals overlap, it means we're not quite sure which one is bigger, And so therefore, we're not going to reject the null that there's no difference, okay? And so indeed, if I go here and I look at this middle one, because that's my two-sided test, again, it's easy to get these things confused. Two-sample, because we're talking about men versus women, and two-sided, because we're saying we don't know which direction it is. Men could have a higher mean, or women could have a higher mean, okay? So we're in a situation where we're doing a two-sample, two-sided test, okay? And so if I go here and I look at my p-value, it turns out to be 0.2241, which is indeed greater than 0.05, and so I would fail to reject the null, okay? And so the last step of my hypothesis testing would be to state the conclusion, and I would say that there does not, based on our sample, there does not appear to be a statistically significant difference in the mean baseline CD4s for men versus women. Okay? All right. Okay, good. And so how would I do this using the drop-down menus if I didn't know this command? Well, I would go to the same sort of spot we were before. Namely, I would go Statistics, Summaries, Tables, and Tests, Classical Tests of Hypotheses, and now a two-sample mean comparison test. Okay? Sorry, actually I went to the wrong spot. So Statistics, Summaries, Tables, and Tests, Classical Tests of Hypotheses, two group mean comparisons. So the variable name is CD4, right? That's my outcome. So I'm just going to scroll down until I find CD4. But now the group variable, the one that tells me group 1 versus group 2, is going to be sex to determine men versus women. And so now you can see we also have this option. This is kind of the nice thing about using the drop-down menus. It gives you all these other options where in the command window we have to know the commands and the syntax, which we won't know. So suppose I want to just relax the assumption of equal variances. So I'm going to click on this unequal variances box. And then I'll hit OK. And you can see now I have the command go for future reference. So before we typed in t-test CD4, comma, by sex. And so now it tells me if I wanted the unequal variances, I would just type the same exact thing, t-test CD4, comma, by sex. But now I would add this word unequal to get the two-sample t-test with unequal variances. Okay? All right. You can see the means are the same. Men 197, women 188. Confidence intervals are there. They still overlap, so that automatically tells me that I would fail to reject the null. I go down here just to be sure. Here's my two-sided test that the difference, remember we said there were two ways to write the alternative hypothesis. It looks like Stata has chosen what we had written as choice B, that the difference between the means of men and women is not equal to 0. And then the corresponding p-values there, 0.2289. So 0.2289 is greater than 0.05. And so we would fail to reject the null and conclude that there's no statistically significant difference between the mean CD4 count in men versus the mean CD4 count in women. Okay? All right. So hopefully you have a good sense for how we do 1 and 2 sample t-tests in Stata. So I will stop there and we will pick up the next time with session 10. All right, see you then.